Alright, so on our dilation worksheet, it says, number one, draw the image of triangle MAT after a dilation centered at the origin. Label the image as triangle FUN. And then it says a scale factor of 2. So before we even start with the dilation, our original image is called MAT, correct?
Mm-hmm.
And its image is going to be FUN. So what is the image of M going to be called? Image of M,
Fun.
F.
F.
Image of A is going to be,
U.
and the image of T is,
N.
remember, they're in corresponding order. All right, now we're going to dilate by a scale factor of 2. What does the word factor mean? Does it mean to add, subtract, multiply, or divide? Think about when we are doing exponents and we're doing 2 to the third power. We use 2 as a factor how many times? So what am I going to do to each of these numbers? So we're using 2 as a factor 3 times. So what does factor mean for us to do? What is it? Multiply. So if we are, so factor, multiply. If we take anything and multiply it by 2, is the image going to get bigger, stay the same, or get smaller? So take any number you want, put it in your calculator. Now, you're going to dilate that number by a scale factor of 2. So factor means you're going to do what? Multiply. So multiply it by 2. Did it get bigger, stay the same, or get smaller?
Get way bigger.
It got bigger, didn't it? Alright, so it actually doubled in size because when you multiply by 2, it doubles. So if we are going to dilate this triangle by 2, do you expect it to get bigger, smaller, or stay the same?
Bigger.
Bigger. Do you think it's going to get closer to the center, the origin, or do you think it's going to get farther away from the origin?
Closer.
Okay, well, let's see what happens. Let's see what happens when we multiply this. So the way that we're going to do this scale factor is the dilation a reduction or an enlargement? Enlargement. Enlargement means get bigger, so it is an enlargement, as we already talked about. Bigger. What do you think reduction means?
Get smaller.
Get smaller. Okay. Okay, so part A was draw the image. The way that we're going to dilate this, we're going to do part C first. All right. We're going to take and multiply the x by 2. Negative 4 times 2 is negative 8. What's the image of M going to be called, first of all? F. Take the x number and you're going to multiply that by the scale factor. 2 times 2 is 4. Now we're going to dilate this coordinate by 2. So we're going to take the x number, the x value, multiply it by 2. Negative 2 times positive 2 is negative 4. Now take and multiply your y number. You're going to dilate it by a factor of 2. 4 times 2 is
8.
And what is the image of A called?
U.
Thank you, me too.
I see.
Now we're going to dilate point T by a scale factor of 2, so we're multiplying the x by a scale factor of 2. Negative 2 times 2 is negative 4. Multiply your y. 2 times 2 is
4.
And what is the image of T called?
N.
Now since we have dilated these points by a scale factor of 2, we just multiplied all of those numbers by 2. We're going to go to the coordinate grid and actually plot them and see what happens to the triangle. Negative 8, positive 4, F. Negative 4, positive 8, Q. Negative 4, positive 4, N. And then draw your sides to your polygon. Did it get closer or farther away from the origin? Farther away. Did it get bigger or smaller?
Small, I mean bigger.
Yeah. And watch this. How long is side MT? 2. And if we multiply this side by the scale factor of 2, 2 times 2 is? How long, so the image of MT is FN. How long is side FN? How tall is side TA?
2.
And if we multiply that by the scale factor, we get 4. So does everything get 2 times bigger?
Yes.
Yep. Alright, so part D. Oh, is the image closer or farther from the origin than the pre-image? Farther. Part E, write the rule to represent the dilation. Well, so we took the pre-image. We took the pre-image, didn't we?
Mhm.
Did we keep it the same or did we change it? We changed it, so arrow, that means changes by. And then what did we do to the X numbers? And what did we do to the Y numbers? Good job, Brayden. He'd already told me before I even finished asking the question. So didn't we take each X and multiply it by 2 and each Y and multiply it by 2?
Yes.
Part F, are the polygons similar or congruent? Similar. And it says explain how you know. They're the same shape, different sizes. Go ahead and stop the video.